For centuries, humans have looked to the heavens and wondered what may lie beyond our solar system. Mankind first turned to telescopes to learn more about space. But when this proved insufficient, advanced technology led to the creation of space probes that could observe Earth's solar system and nearby planets. Only 5 spacecraft launched by humanity have achieved the velocity needed to escape the gravitational pull of our Sun: Pioneer 10 and Pioneer 11, along with the space probe New Horizons and the Voyager 1 and 2 probes. In this video, we will focus on 2 unmanned space probe missions from the early 1980s, the Voyager 1 and 2. Each probe have visited Jupiter and Saturn, in which they yielded data about their atmospheres and magnetospheres. Not only did the probes last until 2013, but they also discovered more than scientists have predicted. We think NASA should have given these spacecrafts more attention because they are pioneers in space exploration and can teach us a lot more. Before we dive into some interesting facts about Voyagers 1 and 2, be sure to hit the subscribe button to watch all of the latest episodes, as Discover Space Channel brings you the most fascinating cosmic discoveries in space and science. In 1972, NASA approved an ambitious project to send 2 space probes known as Voyager 1 and Voyager 2 on a grand tour of the outer solar system. They are now exploring the interstellar median beyond Neptune, since their mission has been extended indefinitely. They were launched 44 years ago: Voyager 2 on August 20, 1977, and Voyager 1 2 weeks later on September 5, 1977. So what was the Voyager spacecraft like? First, let's talk about computers. The Voyager probes contain identical 32-bit computer systems, each with a capacity of 4,848 kilobytes, enough to store a single average-sized JPEG photo file. Each of the space probe's scientific data is encoded on old-fashioned digital 8-track tape machines. Although the tape should look pretty similar to regular listeners of NPR, the data tape recorder manufactured by Odetics Corporation was the primary storage instrument used on both the Voyager spacecraft in the 1980s. The DTR could record data at 2 different speeds, 115.2 and 7.2 kilobytes per second. Exactly what the magnetic tape was made of remains unclear, but whatever those secrets are, they seem to have worked because the DTRs in both spacecraft performed flawlessly from their launch through the entire Grand Tour mission, and even the extended mission that set both of these spacecraft on a course out of our solar system. Voyager's spacecraft can execute about 81,000 instructions per second, making it slower than modern smartphones. If you use a typical broadband connection to download a 5 GB movie from Netflix, it would take you around 8.5 years. But most importantly, aboard each spacecraft is a golden phonograph record containing 115 analog encoded photographs, greetings in 55 languages, and 90 minutes of music. The records also contain a 12-minute montage of sounds on Earth such as volcanoes, forests, and thunder. Let's briefly focus on some of the exciting things the spacecraft have found and the images captured during their missions. Both spacecraft have been traveling along different trajectories and at different speeds. Voyager 1 is traveling more quickly at a speed of about 61,115.7 kilometers per hour, compared to Voyager 2's velocity of 17,241.6 kilometers per hour. Voyager 1 captured incredible images of Venus, Jupiter, Neptune, Saturn, and Uranus. Data obtained from Voyager 1 exploring Jupiter's moon, Io, revealed an erupting volcano on the surface. The Voyager 1 spacecraft was the first to take close-up photographs of the solar system. The most famous image Voyager 1 captured was a picture of the Earth, or what is famously known as the pale blue dot. The photograph was taken February 14, 1990 at a distance of 6 billion kilometers away. And this inspired the title of Carl Sagan's book, A Pale Blue Dot, A Vision of the Human Future in Space. The Voyager 2 spacecraft began transmitting images of Jupiter on April 24, including the infamous Great Red Spot Storm that is 3 times the diameter of Earth. The Voyager 2 spacecraft was able to do this because it made closer passes to Jupiter and the Jovian moons. On August 25, 1989, the unmanned Voyager 2 spacecraft flew by Triton, a moon of Neptune. The resulting data was used to construct a video composite of the spacecraft's encounter. This encounter showed Jupiter's atmosphere in ways never before observed by any spacecraft or ground-based telescope. Between them, the twin Voyagers explored all of the giant planets of our solar system, 48 of their moons, and their rings and magnetic fields. But this would not be all the Voyagers discovered. In fact, they would encounter something far more mysterious and unknown: the termination shock, or helios heat depletion region, where solar wind particles abruptly slow down from supersonic speed to subsonic speed. On August 25, 2012, Voyager 1 entered interstellar space. This happened as the probe left the heliosphere, a bubble of charged particles the Sun blows around itself. As Voyager 1 left the heliosphere, it recorded a 1,000-fold drop in heliopause particles and a 9% increase in galactic cosmic rays that come from outside our solar system. Since then, Voyager 1 has sent back information about the conditions inside dark zone of the universe. One of those discoveries is that cosmic radiation out there is very intense and demonstrates how charged particles from the Sun interact with particles emitted by other stars, and how this bubble of charged particles protects everything in our solar system from those deadly cosmic rays. On November 5, 2018, NASA's Voyager 2 spacecraft registered a sudden decrease in solar wind particles emanating from the Sun, at the same time experiencing an increase in galactic cosmic rays and the strength of interstellar magnetic field just when it became the second probe to enter the interstellar space. The probe had been traveling for 40 years, but on December 15, 2017, it used its backup thrusters to orient itself so that we could communicate with it back here on Earth. With the 70-meter antenna at the Goldstone Deep Space Communications Complex in California yet again operational on October 29th, we are able to signal Voyager 2. The amazing thing is that after all this time and the fact that Voyager 2 is in interstellar space, it returned a signal confirming it had received the call and executed its new commands without any issues. As of January 22, Voyager 1 is 23.3 billion kilometers from Earth, and Voyager 2 is 19.3 billion kilometers from us. The Voyager 1 and 2 probes have begun using their backup power supplies to conserve electrical energy. In 40,272 AD, Voyager 1 will come within 1.7 light-years of a star in the constellation of Fucus. In about 40 years, Voyager 2 will come within 1.7 light-years of a star called Ross 248, which lies in the constellation of Andromeda. But sadly, and much sooner than this, we'll lose contact of both of these spacecraft for good, and they'll pass silently into the interstellar void. One day, in the far-off future, human civilization may have moved so far beyond our present state that we might be viewed as a little more than a curious footnote on our own planet's history. If so, someday someone might find Voyager and power it back up. If this happens, the craft might spin back to life one last time. Thank you so much for watching this video, and if the Voyager's discoveries and facts pique your interest, be sure to comment down below what other amazing cosmic discoveries you'd want to know more of. See you in the next video!